Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Up to N-urikabe by Sudoku. And here are the rules. We have Sudoku, where every row, column, and 3x3 region has to contain the digits from 1 to 9 once each. We have N-urikabe, where we need to shade all cells either blue or green, such that all water cells are orthogonally connected and form no 2x2 areas. Each area of orthogonally connected green cells are called an island. So, as an example, you could have something like this as N-urikabe, where, again, for the blue cells, you cannot have, they must be all orthogonally connected. And what does that mean? It means that you can go from any cell in the blue region to any other cell in the blue region just by going through edges, all while staying within the blue region. So, for example, to get from here to here, you would have to go all the way around here, all the way around here, 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 but you could do that. You could go through just edges, all while staying within the blue region to get to any cell in that region. The land, and also in this, so the land just has, they are form pockets of islands, which they would all be. You also cannot have a 2x2 area where it's all water. You could have a 2x2 area where it's all land. So this is a valid shading here, because this 2x2 area, though it's all land, is valid. But you cannot have a 2x2 area that's all water. So this would not be valid shading, because this 2x2 area would have all water. This 2x2 area would also have all water. And that is N-urikabe. We have circles, where if a circle cell is water, its digit counts the number of water cells in the up to 3x3 area around the clue, including itself. So therefore, if this were water, well, like this is what, if this were the shading, this would have to have 3, because this has 3 cells in the 3x3 box surrounding this cell. But then this would also have to be 3 because of the same reasoning. So this would be problematic. This would be 2, because 2 of the cells that of the 3x3 box that's up to the 2x3 box surrounding it. This would have to be 4, because 4 of the cells in the 3x3 box surrounding it are water. If a circle cell is land, its digit counts the number of cells in its island. So, for example, well, this is problematic here. This is also problematic. Okay, so let's just make it blue there. Or let's make it, I don't know, blue here. This is the number of cells on its island is basically the number. This would be 9, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So both of these then would have to be 9 in this example. This would be problematic because they would both have to be 8. But obviously that's not going to work. So the shading obviously doesn't work. Anyways, that's how circles work. And we have up to n sums, where clue outside the row or column n indicates the sum of all digits up to that cell and contains the digit n. Sorry, that was not phrased well. A clue outside the row or column n indicates the sum of all digits up to the cell that contains the digit n. The digit n itself is not included in the sum. So for example, this says 8. That means all the digits up till the 1 that you see in this grid must add up to 8. This is 18, so this is so obviously this doesn't work, because if this were 3, you can't have the first 6 digits add up to 18, which is impossible. But in this case, it's basically all the digits until the 3 add up to 18. All the digits here until 3 add up to 18 also. Moreover, all cells before the digit n have the same shading, and the cell containing n has the opposite shading. In other words, the sum entirely consists of water and n is land, or the sum entirely consists of land and n is water. So, obviously this doesn't work. Let's just use this as an example. Say it was 4 here. That means these digits would have to add up to 21, and either these are all water and this is land, or they're all land and then this is water. That's what the up to n sums mean. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So this is this is up until 1. What is the digit? So this is either 1 digit or it's 2 digits adding up to 8. So 1 has to be one of these digits here. We're not sure which. This is 3 digits. This is 3 digits. So these are the same shading. Well, if this were land, that means there would be a pocket here. Well, you could have multiple lands here. This is all the same shading, though, so let's mark it as pink. And it could be 3. So 3 could be here, 3 could be here. This is also 3. But we don't know if the shading's different. The shading could be different. This is at least 4. This is at least 2. This is at least 2. This is at least 3 here. This is at least 4 here. This is at least 3 here. This is at least 3 here. And this is at least 3 here. Okay. So these are the same shadings. Okay. So how does this work? We know if this is land, this all has to be land. And that does not work. Because you can't have 3 digits here adding up to 8 because it's up until 1. So you cannot include 1 here. So if this were all land, if these were land, this would have to be all land. Because all the water needs to be connected. And the only way you can connect is just with the only way then that this would be all the water would be connected is if this were all land. So this cannot be land. This has to be water here. This is water, so this cannot be water. This must be a land here because it's 2x2 area. Can this ever be water? If this is water, then land does work if this is both water. Water and land works if that's water. This could be land by itself with water there, and that's land. So we don't know. This is basically, this could be up till 4. So this is 1 through 4 of the island size. This cannot be all water, because if this were all water, the problem is this 2x2 area would not, would be all water, which is not allowed. So this must be land. And that means this stops here, so this is a 3 here. Since this is 3, you can't have 2 digits adding up to 21 with 3. So you need another digit at least. So this is at least there. This can't be water. So this has to be land. And then the water has to be orthogonally connected. Technically, you have to have water somewhere else in this grid. So this has to be going that way. Therefore, this is how many 2 digits? Up till 4. So this is 4. You have to continue, so that's blue. And this is 5 digits, which is the maximum you can have in the same row to add up to 18. So then this would be green. This could be 3 blues. That's possible. Or it could be 2 darks. This would be 3 then. 5 digits adding up to 18. Without a 3. It would be 1, 2, 4, 5, 6. Yes, 1, 2, 4, 5, 6. So this has to be 1, 2, 5, 6. 1, 2, 5, 6. 1, 2, 5, 6. 1, 2, 5, 6. So that means these 3 digits are 7, 8, and 9. That means this is greater than 3. Because you can't, without 7, 8, or 9, this is at most 4, 5, and 6. So this has to be at least 4 digits here. This can't be 2, because if this were 2, this would be all 20 up till that. So there's no 2 here. This can't be 1 because of the size here. So this is either size 3 or size 4. Interesting. We know this is at least 4. Remaining digits in box 3 are 1 through 6. These can't be 1. So we know 1 is part of this. Interesting. Is this water? This has to be 5 because it's up. Well, we don't know. It could be blue here. And then blue here. That's possible. Never mind. This could be all land. Say this was just 3. This could extend further. That's fine. If this is 4, that means all of these are the same shading. I mean, it could be a land, maybe. Oh wait, no, this has to be including this. Because this is up till 9, right? And also this is a 7, 8, 9 triplet, so therefore if this was a 7, 8, 9, that would include that. Sorry, that would eliminate all possibilities for that cell. So these are the same shading. 2 cannot be here because, well, no, you can't have 6 digits adding up to 2. This can't be 1, okay. Yeah, because 1 has to be one of these 2 in this box. So this is a 2, 5, 6 triplet, which eliminates 2, 5, 6 here. So this is 1, which means this must be the same shading. So this is blue. It could be 1 more, or it could be 2 more. Sorry, it could be 1 more, or it could be these 3 by themselves. So one of these is 4. If this were... No, sorry, one of these is 5. Apologies for that. That's interesting. Say this wasn't a 5 and this was 5. Well, it could be... Could be really any digit there, supposedly. 3 is here. This is 18. And it cannot include 2, 5, or 6. So this can't be 1. If this were 1, the problem with that is that 1 plus another... It has to be 1 plus 8 plus 9 adds up to 18. But it can't be. So this can't be 1, which means this is the 1 here, which means this is 8. This switches here, so this must be 3. Which means 3 cannot be any of these. 2 can't be here. Because it's up till 2 for this sum. So this switches, which means this is both green. Remaining digits are 4, 7, and 9 in box 1. Okay. 4 and 7 would have to be with 7 to add up to 18. 4 and 9 adds up with 5 to 18. 7 and 9 adds up to 2 with 18. So this is what? 4 and 9 and 7 and 9. So this is guaranteed to have a 9, which means this can't be 9 here. One, 2, 4, 5, 6 adds up to 18. This is either 6, 9 or 7, 8, adding up to 15. Remaining digits. So this... What adds up to 20 without a 2? Can you add up to 20 without a 2? And the answer to that is no. So these must all be green. Sorry, with 5 digits, I'm thinking. And without a 3 now. This has to be 4 digits adding up to 20. Because 5 digits can only add up to 20 if it's 2, 3, 4, 5, 6. And we can't have 2 already, so that doesn't work. So this is land, which makes this water. Okay, so let's start drawing boundaries that we know. So this is a boundary, this is a boundary here. This is boundary here, this is boundary here. So this must be 2. 1 and 2 can't be just 3 digits, so this must be 4 digits. And it had to go out anyways, because if it didn't go out, this was blocked from all the other water that's in the puzzle. So then it goes here. So this is boundary, so this must be 4. 2, 1, 4, that's 7. 14 minus 4. 14 minus 7 is 7. And this is 5. So this cannot be 7, 8 as a pair. It's 6, 9. Whereas 8 in box 2 cannot be here because of 8 in the row. So this is 8 here. That leaves this as 5. This can't be 5 here. This could all be water, though. This could be land. We don't know. So this is done. So this is done, too. So this could be all... It could be all water. Actually, it has to be all water. Ooh, that's interesting. So this is all water here, because it changes after the 5. And the water has to be orthogonally connected, so this has to be blue here. So this is all blue. Okay. This has to be... It could be 4, 7, 8, 9, and everything else requires 5. So this must be 4, 7, 8, 9. This can't be 4, obviously, or 9, because of 4, 9 in the column. 4 and the 6, 9 pair in the column. This is border 2. And now this is border. I guess we should do borders around the entire grid, too. This can't be water. If this were water, the problem is it would not be orthogonally connected to the rest of the water. So this is land, which makes this water. This has to be land. This must be land because of the 2x2 areas around it. This must connect out to be orthogonally connected to the rest of the waters. So this is a boundary. These are, well, they could both be... Okay, so this cannot be water. If this were water, you don't have enough water cells to get to 7, 8, or 9. So this has to be land here. It already has 6 here. This adds up to 21 without 4, so it's 3. So the rest of the 3 digits are add up to 18. Remaining digits in row 5 are 1, 2, 3, and 6. This can't be 3. So 3 can't be here. 3 has to be one of these 2 digits here. This is until 2. 2 cannot be here. Can 2 be here? Yes? Hold up. So if this is 2, what's the max this could be? It would be 2, 6, 3, and 1. Which means that's what? 12? 45 minus 12 does not work here. So this cannot be 2. So therefore this has to be 2. Which means this is 7, 8, and 9 here. So this is a different color. So there's a boundary here. This is 7, 8, 9 as a triplet, which eliminates 7, 8, 9 in the rest of the column. So this is 4. This can't be 4. This can't be 4. That leaves this as 5 or 6. We have a 9 guaranteed in one of these 2. Adding up to 18 with 5 or 6. You don't have 4 available. You already have a 3. Can you have 2 or 1 with 5 or 6? The answer is no. 2 and 6 at max adds up to 8, but that would leave the other digit as 10. So it cannot include 1 and 2. It cannot be 3 and 4. This has to be a 5, 6, 7 triplet. So this is 5, 6, this is 5, 6, and 7. And this is 6 or 7. Cannot be 5 or 6, so this is 7. Which means this can't be 7. This is 5 or 6. 7 eliminates 7 here, so that's 8. This is 8, which eliminates 8 in the rest of the row. So this becomes a 7, 9 pair, which leaves us 1 and 8 as a pair in box 4. And this 8 eliminates 8 here, so this is 1, which makes this an 8. Can you ever have 8 cells be all water? I think the answer to that is no. Right? If you have 8 cells all water, the problem is you're guaranteed a 2x2 area that is all water, which is not allowed. So this must be land. Okay. This can't be the same, then this can't be both the same land. This must be water here, then. So this is boundary. How many cells does this add up to? We have 3. It has to orthogonally... Well, it could orthogonally connect some weird way. So this is at least 3. It cannot be 4, 5, 6, 7, 8, 9. So it is 3. Oh. Which means this is all water. This is 1, 2, or 5. That means this cannot be water. This is all land. So this is already 1, 2, 3, 4, 5, 6 in size. If it included this, it would be 7, 8, and 9. That doesn't match the number of cells on the island. So this must be water. This is water. This is land. This must connect to water, because otherwise it's blocked here. Oops. So this is boundary. This is a 2x2 area, which is all water with 3 water. So this must be land. This is likely 2, would be my guess. 8's here. This is 9, so this can't be 9. This is 7. This is 9. So this has to be... Oh, this is not 2. Okay. Wait, this has to be 2 either way. Either this is 2... Oh, it could be 3. It has to be 3 then. Okay. So this is 4, 9, and 5, adding up to 18. That eliminates 4 and 9 in the rest of the box, so this is 7. This adds up to 20 with 8. So we have 1, 5, and 8. 1, 5 is 6, plus 8 is 14, plus 6 adds up to 20. So this is 1, 4, 6, which eliminates 1, 4, 6 in the rest of the box. So this can't be... Sorry, 1, 5, 6. So that eliminates 6 in the rest of the box. Ugh. This is 2, 3, and 4. This must be water. So that eliminates 6 here, because of the 1, 5, 6 triplet in the row. So this is 9, this is 6. 9 eliminates 9 here. So it's 4 and 9. So this water must connect orthogonally, so it goes there. So this is either 2 or 3. It can never be 4. This 5 eliminates 5 here, so it's 6, which makes this 2. 6 eliminates 6 here, so it's 5 and 6. This must be 3 water, cannot be an island, because island would be only size 2. So this must be water here. And this sees 3 cells that are water there. That's 3 in the corner. We celebrate because we know we're getting close to solving this. Remaining digits in column 1 are 4 and 5. Remaining digits in column 3 are 1, 2, and 6. Okay. Remaining digits in row 4, we have 1, 2, 8, 9. This can't be 8. Remaining digits, this is 7, 8, or 9. We have 1 more digit there. This is 1, 2, 3, 4, 5, 6, 7. We can have 1 more green here somewhere. We have to have 1 green, I guess I should say. This is water cells. It must be 4 or 5. This has to be a 6 here. So that means the remaining digits here must add up to 25, do they? 4, 5, 7, 9. 4, 5 add up to... 4, 7, 9 add up to 20. Yes, that works. So this cannot be 4, 5, or 7. It's 9. because of 4, 5, 7 in the box. Therefore, this can't be 9. This can't be 6. This must be 4, 5, and 7, and it does work, adding up to 25. So this is boundary. So this is done, 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 that's done, this is done, this is done. 24, we still haven't done that yet. This is done. This is up till 9. This can never be 9 because that's too far away. This can't be 9 anymore. So it must be 9 here. This can't be 22 digits. No, summing to 22 for 7 digits. So this is 9 here. This is all water. That means it gets to here, and then this becomes a 9. So this must be land. That means this is boundary. We know the water has to connect orthogonally, so this must go this way. This is a 2x2 area that's all water, so this can't be water. This is land. This sees 4 digits in the 3x3 box that surrounds it. So this is 4, which means this cannot be 4 here. This can't be 4, an island 4 in size. If this is all land, it cannot connect to this island, because then that would be way too big of an island. So this must be 3, which means this is water here. Since this is water, this 2x2 area has 3 water, so this can't be water here. This must be land, and this is the 8 that's there. 1, 2, 3, 4, 5, 6, 7, 8. So that's done, which means these are both water. So this is water, this is water. This 2x2 area has all water in 3 cells, so this must be land. And this, okay, so if we try to connect this as land and land, the problem is that's size 3, and that's not allowed. So this must be water this way. So this is done. And this is size 1 island. So this is 1, which eliminates, this is 1, which eliminates 1 here, here, and here. This 2x2 area has all water, so this can't be water. This is island. This cannot be the same as this, so this must have a water in between. This 3 eliminates 3 here, so this is 2, which means this can't be 2 here, no 2 here, here, and no 2 here. And this is 2 for this this water area. So this must be land. So this is done here. This is 1, 2, 3, 4, 5, 6, 7. So now we have this being valid if these are water. We don't know. This must add up to 22 without a 9 and with a 4. So 22 minus 4 is 18. It could be 4 with 5, 6, 7. It cannot have... Okay, remaining digits in column 5 are 3 and 8. This can't be 3 because of 3 in the row, so this is 8, which makes this 3. Remaining digits in column 6 are 4, 6, and 7. So this can't be 4, that's 6 or 7. I think it has to be 4, 5, 6, 7, adding up to 22. With 2, it can only be 2, 7, 9, adding up to 18 outside, and 1 is not allowed. So it cannot be 2 here, so which makes this 2. So this has to have 5, 6 guaranteed. And 4, 5, 6 is 15, which means it's 4, 5, 6, 7. So this can't be 7, this is 8. These can't be 8 here. This 2 eliminates 2 here and 2 here. This is up till 9 here. So this has to continue here. And 5, can you have 6 digits adding up to 24? The answer is no. So this must be 9 here, and it swaps there. So that's done. This is a 2x2 area that is all water, so this can't be water. This is island. This cannot connect here. So this has to be, this 9 eliminates 9 here. These can't be 9. These add up to 24. So 24 plus 9 is 33. 45 minus 33 is 12. So this must be 12. This cannot be 5 or 6 then. Because with 5 here, at minimum, that's 3, 5, and 7, which is 15. So this must be 1 here. No 1 here, no 1 here. And it has to be, this is adds up to 12. It's 1, 3, and 7. That's 3 in the corner. We celebrate because we know we're close to solving it. This is 4, which eliminates 4 here. This can't be 1 or 3. It's 2 or 6 here. No 7. We have a 5, 7 pair in row 6, which eliminates 5 and 7 in the rest of the row. This can't be 5. This is 4. So we have boundary here, boundary here. 1, 2, 3, 4, 5, 6, 7. This can't be 7. It's at least 8. Remaining digits. This 3 eliminates 3 here. Where is the 3 in row 5? It has to be here. So this is size 3? How is this 3? It can't be 3. Fail. I was so close, too. Dang it. Everything else is working. So the problem is this can't be 3 in size because you already have 4 there. Dang it. That's not good. Everything else works. Okay, so maybe is this assumption? Ugh. I don't like this. That sucks. Okay. Maybe it's this assumption. Oh, but I don't know how else you can get that. I think it has to be 3, right? This can't both be water. Dang it. It's almost leading it to 3. This can't be 9 here, so this includes this, which means this is land. One, 2, 3, 4, 5, 6, 7. So then this has to be green. It's 9 here. 24 plus 9 is 33, so this is 12, which makes this 1. Because 5, 2, and 7 never adds up to 12. It's 14 at least. So this can't be 1. No 1 here. So it's either 2, 8. This can't be 9 anyway, so... No. 1... Oh, that was where I messed up. Right, this adds up to 12. Okay, so that's the problem. So then this is still 3. We have 2 there. Okay. Yeah. Okay. So this is not 2. Yeah, the logic here was all valid. I just messed up the actual, like, execution of the water, sorry, the size. So this is all the same. This way. This is 8, 1, 2, 3, 4, 5, 6, 7, 8. So therefore these are boundaries here, which means these are both water. This is all water, so this must be land. Again, it cannot be... So this is 4... you can't have a 2-size island here. You can only have 1 or 3. So therefore, this has to be water. This is 1. This is 5, 6, 7 here, which makes this 2. This 8. No 8 here. No 8 here. No 2. No 1. This is 3 and 8. This is 8. This is 3. We have 4, 6, 7 here. This can't be 4. We have 5, 6, 7 here. This is 1, and the rest must add up to 11. So it's 3, 8, or 4, 7. So either of those could be the case. This is land, because we know this has 2 water islands around it, or 2 water cells around it. So that's land. This is done that way. This is a 2x2 area that's all water, so this must be land. This cannot connect, because if it did, that would be too large of an island. So this is water. This can't be 2 or 3. If we try to have this... Okay, so if we try to have this be 3... then this would be 3 there. So this island can't be 1, can't be 3, can't be 6, because that would then connect to this, so this must be 2. So this is 2, 1, 2. This cannot be 2 or 9. No 2 or 9. This 1 eliminates 1 here, so this is 6. So this is done as an island, so this, oops. This is, can't. Okay. So this is water here. This is 2 as an island. This can't be 2 or 6. Therefore, it's 3. 3 eliminates 4 here. 3 here. So this is 4. This is 3. 4 eliminates... This is 1, 4, and 7, adding up to 12. So this can't be 7 here. This is 8 or 9. This 4 and 7 eliminate 4 and 7 here, so it's 5, which makes this 7, which makes this 4. Therefore, this can't be 5 or 7. It's 6, which makes this 7, which makes that 5. That leaves this as a 2-8 pair. So just to make sure it adds up, 2 and 8 add up to 10. 6, 5, and 3 add up to 14. That adds up to 24. So this is 2, this is 8. 2 eliminates 2 here, so it's 6 and 2. This can't be 6 or 7, so it's 4, which makes this 6. 4 here eliminates 4 here, so it's 5 and 4. 5 here eliminates 5 here, so it's 1 and 5. That leaves this as 7 or 9 here. Remaining digits in row 8 are 1, 7, 9. Okay, this is 1, 2, 3, 4, 5, 6, 7. So this is done. It could be both 8 or 9. Okay, this 5 eliminates 5 here, so this is 6, which makes this 5. This can't be 7. Okay. So all of these are done, right? 8 adds up to 1. It's 8. Up to 3 is 1, 2, 4, 5, 6. 4, 5, 6 is 15, plus 3 is 18. Up to 4 is 3, 5, 6, 7. 5, 6, 7 is 18, plus 3 is 21. Up to 5 is 9, 6, 9, 4, 7, 8, which is 28. Up till 2 is 1, 5, 6, 8, which adds up to 20. Up to 6 is 5, 4, 7, 9, which is 25. Up till 9 is 4, 5, 6, 7, which adds up to 22. Up to 2 is 7, 8, 9, which adds up to 24. Up to 3 is 4, 5, 9, which adds up to 18. Up to 4 is 6 and 9, adding up to 15. Up to 5 is 7, 2, 1, 4, which adds up to 14. Up to 9 is 2, 8, 3, 5, 6, which adds up to 24. So those are all done. The question is this part here. So this could be 9. If you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Can it be 8? No. If it's 8, you would have 8 here, and this would have to be a different island, so therefore this would be water, but the water's not orthogonally connected. So that does not work, so then this must be 9, and it must connect this way. And this is the N-urikabe. So this is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9, which eliminates 9 here, so it's 7, which makes this not 7. This is 9, 7. This can't be 7 or 9. It's 1, which makes this 9, which makes this 1 eliminates 1 here, so that's 8 and 1, and that leaves that as an 8. Okay, so aside from a little miscalculating here, this wasn't that bad. I don't know. It seemed fairly... I don't think I would consider this hard. I think I would classify this as challenging. Because the logic is very solid throughout. It's very easy to make... The logic's very sound, right? And it flows very well. And it's not hard, right? You just have to know how far it can go, and then you basically say what happens if this is land and what happens if this is water, right? And then the circles help you a lot disambiguing things. I would classify this as challenging, not hard, but I don't know. Maybe that's just me. Either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.